repository of authors and researchers presenting their work. And overall, our hope is that we can make finding relevant machine learning information and research papers, we want to make that a bit easier for everybody. And we also host workshops and socials. And in general, it's just the community is a great way to get involved and get to know what's going on in machine learning and level up your skills. So yeah, I'm excited to be partnering with our friends at General Assembly for this event, for this specifically this AI ethics event. But yeah, I'm really excited to have you, Matt, and just having somebody with your level of expertise and experience and interests in AI ethics joining us. I know I'm going to learn a lot today. Anyways, so Matt's talk today is titled Detecting and Correcting Unfairness in Machine Learning. So Matt will be taking us through a high-level discussion of what fairness means in machine learning, and then he will cover different methods that can be used to detect whether or not unfairness is present in a machine learning application, and he'll also outline some methods that can be used to make applications more fair. I think it sounds super interesting. So yeah, thanks again, Matt, for being here, and if you're ready, please go ahead.
Yeah, thank you so much, Serena. I appreciate it. All right, so I assume that you're able to see my screen. Serena, please come on my.
Looks good.
So yeah, this is just my background. I've already said this, so I'm not going to go ahead and rehash that. But the slides that I have here, I'm very happy to give a copy of slides to people afterward. So I'll work with Serena and Joshua to make sure that this is this can be distributed if you would like. But thank you all so much for being here tonight, and I'm excited to get into talking about correcting bias and fairness here in machine learning, because it's such an important topic. So the agenda, we're going to go through three main pieces here in the 15 minutes that we've got. The first is going to be something that many of us, but not all of us, are familiar with: the idea that accuracy tells one part of your story. Then we're going to get into the notion that any one number summary that we talk about tells one part of the story. And we're going to get into specific components about how models cannot responsibly be reduced to one number. We're going to talk about this in a few different contexts, and we're going to discuss, as Serena mentioned, a couple of techniques for understanding what are some of the fallacies when we do reduce things to one number, and what are some ways of maybe detecting that, and hopefully some helpful tips for how we can avoid or how we can try and correct that, especially when working with other stakeholders. So what you see on the screen, we've got accuracy tells one part of the story. And those of you who come from a data science background will recognize at the top, we have a lot of different methods for classification, model evaluation. So I build a model and I want to predict, for example, is this person likely to default on their loan? Well, we might say that that model is 99% accurate. It will predict the correct outcome 99% of the times. Now, there's all sorts of reasons why maybe accuracy is not the right metric for us to use. Again, people with more data science background will remember this from whenever they learned it or from their personal experiences. But to be as inclusive as possible and make sure that everybody can follow along, there are cases when maybe that isn't the right call. So for example, let's say that 99% of people do, I'm going to jot this down on my slides here. Let's say that 99% of all people do pay off their loans. These are made up numbers, so I do not know how accurate this is. So please do not take this and refer to these numbers as if they're true in any sort of way. But if 99% of people do pay off their loans, that means that 1% of people default or do not pay. They default on their loans. That means they do not pay off their loans. Well, I can get a 99% accuracy score if I just predict that every single person, I predict that 100% of people do pay off their loans. Now, that's going to be a bad model, because if you work for any sort of organization that works with loans, you will never ever predict that somebody does default on their loan, which is probably the point of the data science model that you want to build. So you might turn to all sorts of other metrics: sensitivity, specificity, precision, the area under the ROC curve, all of those things listed at the top. We refer to those as a bunch of different methods for evaluating a classification model, where we're trying to put things into one bucket out of many buckets. So in this case, we're trying to predict every single person. Are you going to pay your loans off on time, or will you default on your loans? And we want to be able to evaluate that model that we generate predictions from. On the bottom, you're going to see the same sort of thing, but in the context of a regression problem. So let's say that instead of trying to predict whether or not people pay their loans back, instead what we want to do is we want to predict what is the credit limit that each person should get. Well, in that case, it's not like we're trying to predict people into buckets, but we're saying we're predicting any sort of outcome reasonably from 0, theoretically up to an infinitely high bar. We're saying, what should their credit limit be? And we can use all of these metrics at the bottom here to try and evaluate that. Mean squared error, mean absolute error, R squared or adjusted R squared. So you see a lot of these different metrics here, and this drives home a point that is really important for us to think about, and that's that accuracy tells one part of the story. However, where it gets a little bit different is that we need to think about the fact that any one number summary, and I'm going to emphasize this, any one number summary tells one part of the story. So we know that we could perhaps use sensitivity if we really want to optimize our true positive rate. But that still is going to conceal a large part of the problem. So 3 points that I want to make here. The first is that whenever you do a one number summary, that's going to necessarily, it's summarizing. So it's necessarily going to leave part of the story out. So let's say that you were to take a full column of data and you said, instead of reporting my full column of data, maybe all credit scores that exist or the number of years of experience that people have, and I just report the mean or the average number. Well, how does that mean tell or not tell the full story? And this isn't necessarily just a data science thing, but we recognize that anytime we hear a number that says the average income in a certain area or the average number of years of experience in among a certain group of people or whatever, that leaves out so much of the story. So anytime we come up with a one number summary, that's really going to leave out a large part of the story, even if we as practicing data scientists know, let's avoid using accuracy or mean squared error in every situation. There's often a conflict here as well. If your model performs well on one metric, it probably doesn't do too well on others. So if you want to optimize for true positives, or rather, let's say you want to minimize, if your goal is to minimize the number of false positives that your model gives you, many of the techniques you're going to apply or many of the models that you fit that try and minimize false positives will end up increasing your number of false negatives. That can have huge consequences. If you're building a model that has to do with disease detection, for example, a certain type of cancer or COVID or any type of thing, if you build a test, like a medical test that minimizes false positives when we incorrectly think that somebody does have a positive COVID test, well, many techniques that we use to do that are going to increase the number of false negatives that we have as well. So there's often going to be a conflict between one of our summaries and other summaries that exist. And finally, and this sort of cracks everything open in terms of what I want to emphasize here, thinking about a global metric versus a local measurement. When we summarize our models with one number, we're providing a global summary of our model. So if I go back to the example that I had earlier, and I said that our model was 99% accurate, that means that it's 99% accurate among all individuals, our full population. But oftentimes this leads to disparities in local subgroups or when we're looking at smaller groups of individuals. So for example, let's say that the measurement that I want to do is called sensitivity. I'm looking at my total number of true positives over my total number of positives in my data set. And if I have 1,000 individuals, it is possible that I get a sensitivity score of 99%. I'm actually going to change this to orange. so that it's a little bit easier, hopefully, to see. 99%. Well, 99% accuracy among all 1,000 of those individuals, that full population. Let's say that I break this out into two different groups of individuals. Let's say, for example, that I want to break this out among people who, let's say that we're looking at white people and people of color. Well, if white people make up the majority of the people that I'm looking at, group one down here, if that's white, perhaps my model or my algorithm works really well and actually has a 99.5% sensitivity score among that very, very large group of people. However, let's say that in the sample, due to maybe data collection issues or whatever mistakes that some people are making throughout the processes, whatever biases are coming in here, for subgroups that are less represented in my training data, let's say that here my sensitivity score is much lower, or my true positive rate is much lower and is only at 50%. Well, by focusing on my global summary here and saying to my boss, well, I've got a 99% sensitivity score. That's really good. We're happy with that. What that does is that masks local disparities. The term that we often use to describe this is called prediction quality disparity. Another way of saying that is that my model performs better or has a higher predictive quality on one group of people than on another group of people. Certainly doesn't have to just be limited to people, but a lot of times it does have to do with individuals and humans. And so that's a really important problem to be aware of, this notion of prediction quality disparity. So when it comes to metrics for detecting bias, rather than just looking at accuracy globally or sensitivity globally, what I would encourage you to do is also look at this broken down by important subgroups in your data to be aware of this type of prediction quality disparity that may come up. It's not just for sensitivity, it can really be for any predictive metric you have. If I move on to the next slide, if you worked at a company that made soap dispensers, so a common challenge that has come up is people are talking about soap dispensers that work really well for people with lighter skin, but for people who have more melanin or who have darker skin colors, those soap dispensers may perform measurably worse. So I want to think and challenge you to think about what you would do if you were working at a company that makes soap dispensers. Maybe if I move back to that last slide, historically, people might be okay with saying I've got a 99% sensitivity score or a 99% true positive rate. However, that's not necessarily or that's not something that's going to be deemed as ethical. That's not going to be something that in many cases is deemed as fair. And we need to be aware of this and cognizant of this to understand what are changes that we can make in our role as data scientists. So there's some common data science techniques you can apply here. You could gather more data from minority classes. You could try and optimize for a different metric. So maybe you optimize for sensitivity or accuracy or specificity or the area under the ROC curve. Or, and this is an important point here, you fit a different model that has a smaller predictive quality disparity. However, this may make your overall performance go down. And this is an important point that I want to emphasize. So maybe instead of getting a model that has a 99% sensitivity, you fit a model that has a 95% sensitivity, but has no prediction quality disparity between these two groups that we were looking at. For white individuals and people of color, perhaps everybody has the same true positive rate at 95%. And that gets into a very real world challenge. It's hard to convince your organization to do this, but in my opinion, this is your responsibility as the data scientist. It's your responsibility to tell this story. Because yes, part of what we do as data scientists is we focus on the math side of things and the computing side of things. But we also need to be able to communicate and tell the story of the data to people who might be making those decisions. So people in finance or people in public relations or people in the marketing team or people who may not have the same level of technical depth or expertise as us. It is our responsibility to argue to them that in this case, perhaps it would be better for us to have a model that performs worse globally, but better locally. So who tells that story? You do. And that's something that I want to encourage you to focus on. because it's something that we tend to not focus on a whole lot when it comes to the rigorous training of data scientists. We focus on looking at all of those different metrics and seeing which one is best. But when it comes to doing a subgroup analysis and looking at how our models are affecting different groups of people, that is very, very important. And this gets me to the last component here, that models cannot responsibly be reduced to one number. If you think about a model, my favorite definition of a model is that a model is just a simplification of reality. Now, to take a very basic example, you might think of your commute time, how much time it takes you to get to work, assuming that you're commuting to work, or if you think back to when you were commuting to work. If you take your own commute time and reduce that to one number and just say, you know what, every day it takes me 60 minutes to get to work. That's not always going to be accurate. Some days it'll take more, some days it'll take less, but that's a good mental model for you to have. That's probably okay to reduce to one number because you are the person who's most affected by this decision. And let's say that you consistently undershoot how long it takes you to get to work and you are repeatedly late. Well, then you have the ability to change that mental model. And it, again, is only affecting you. But when you're building a model that forecasts things for other individuals, that cannot responsibly be reduced to one number. So in this case, I mentioned the probability of voting and want to walk through a very quick example with this. Political campaigns are bound by finite resources. Politicians in the United States are constantly asking for money from individuals, trying to amass as much of that as they can. There's a finite amount of time, only a certain number of hours in the day. And the goal for many individuals is to get 50% of that vote plus one vote. It's not always going to be the case in the US. We've got the Electoral College that makes that different, but it's kind of not, that's immaterial to what I'm mentioning here. So the goal is to get 50% of the vote plus one. So the campaign says, totally reasonably, how can I get the most voters for the least amount of money? Well, when you try and focus on, and I'm going to write this in a different way, the focus is efficiency. How can I maximize my efficiency? How can I get as many individuals as possible in my bucket for the smallest amount of money? Well, this has a lot of impacts. This may disadvantage young people because historically, young people haven't voted as much. So for a campaign, if they say who's more valuable to me as a voter, young individuals are not necessarily worth my time. And that shifts the political system and thinks about when it comes to power and politics, shifts it towards older individuals, people of color. And related, people have historically been disenfranchised. So people who may be segregated in a place that's not easily accessible, people who have historically been disenfranchised and not been able to vote in the past, so they're deemed unreliable voters. And so a campaign says, well, I would have to pay $10 to target one voter who's been disenfranchised, or $2 to somebody who I know has shown up to all of the most recent elections. Same sort of logic applies to voters in rural communities where you may need to take more time to go and conduct outreach to them. So all of that is to say is that political campaigns are bound by finite resources. And so by focusing on efficiency, trying to maximize that efficiency, getting the most voters for the least amount of money, that disadvantages a lot of groups of people. But it's not just politics. Who else is going to be bound by finite resources? If you think about your boss, you think about your team, you think about your company, competitors' companies, and all of that, organizations are going to be limited by time and money and perhaps other things. And so it's important for us to recognize that when we focus on that one number of efficiency, however efficiency is described or is quantified in your context, in many cases, that will disadvantage certain groups of people. And so that's very, very important for us to focus on. So when we think about that, every organization is bound by some sort of finite resources. And so it's important for us to identify who are disadvantaged by this. One method of detecting bias, so in addition to the prediction quality disparity that I had talked about earlier, one other measure of bias that you can use is called statistical parity difference. And it's just a difference in conditional probabilities. So what you might do is you might look at in this case, let's say that y equals 1 is the favorable group. So you were trying to see how many people, favorable group. So how many people are predicted to be in that favorable class based on our model? And you might look at that among, again, different subgroups. So in this case, if I wanted to look at men and women, or in this case, I'll keep it consistent with what I've written on here, female and male. And we're trying to understand what's the probability that our doctor detects, in this case, chronic kidney disease. Well, we can see if there is parity or disparity between these two groups. Your statistical parity difference can range from -1 up to +1. If you have values close to 0, that means that the probability of doctors detecting a disease among, in this case, females and males, there's more parity or there's less disparity. But if those values are farther from 0, the closer to +1 or -1, that means there's going to be more disparity between those groups. In terms of identifying the effect of your model here, I call this statistical parity difference of our data. And that's why I've written SPD data up there. What we can do is we can calculate the statistical parity difference on our data, and we can also do that for our model. So notice that here I've got what's actually going on in the data, y equals 1, y equals 1. But if you also apply this to your model predictions, y hat equals 1, y hat equals 1, you can then look at what is the statistical parity difference in your data and what's that statistical parity difference in your model. If your model statistical parity difference is farther from 0 than your data statistical parity difference, that means that your model is exacerbating inequities in your data. So for example, if let's say that your statistical parity difference here were -0.1, that means that your doctor is 10% more likely to detect chronic kidney disease among males than among females. However, if you build a model trying to detect chronic kidney disease, and you now have a statistical parity difference of -0.15, that means that your model has exacerbated that difference and has, in this case, made things a bit worse. You can do this. This is not just limited to binary X variables. And I want to make a note here that in this case, as the way that I've written male and female, we are comparing two categories. But as we think about gender and sex, it's very important for us to recognize that this is not binary. So I want to make sure that I state that. In addition, you can do this for any discrete X variable by comparing all pairs. And you can even use Bayes' rule to derive this for continuous X variables and using kernel density estimation to be able to understand what this might look like if you wanted to change this instead of looking at two categories, but instead you wanted to look at this among ages or something that might be a bit more continuous in nature. All of this rounds out, and I know I've gone a little bit over time, this all rounds out in terms of it is up to you. We recognize that it is ethical to avoid harming individuals. By ignoring biases, the story that you may tell as the data scientist may actively harm individuals. And it can be really challenging to think about how would you tell a client or how you would tell a manager that their approach is flawed or can cause harm. And it's important for you to think now, and rather start thinking about this now. How will you respond? Those of you who are looking to break into the data science field, it's much easier, and I imagine many of us who are actively in the data science field would affirm this, it is much easier to think now about how you would respond in this sort of situation, where you may have to say, it would be better if the model performed worse globally, but there were fewer inequities in our data. That's something that it's easier to think about this now than to wait until you are in a meeting and your boss asks you to do something or a client encourages you to do something and you are more uncomfortable with it there. So I would encourage you to start thinking about that now. This rounds out with what I wanted to bring up. So accuracy tells one part of the story any one number summary is going to tell one part of the story. I did add in here the two techniques that I had talked about, looking at prediction quality disparity among subgroups and looking at statistical parity difference. You can look at that for your data. You can look at that for your model. And you can look at that for both if you want to see if your model does exacerbate existing inequities in your data. And this all brings everything to models cannot responsibly be reduced to one number. And so it's important for us to be circumspect when we are building machine learning models, especially those that are going to affect human lives. So I'll pause here. So thank you all very much for that. I want to welcome Serena on to be able to ask questions, as well as if there are questions that other people have that you would like to bring up, please do feel free to put it into the question and answer section. And I'd love to hear from all of you about any thoughts or comments that you've got.
Thanks, Matt. That was awesome. You are a true lecturer. I really love how you write on the slides and it makes it really engaging. I'm thinking I might have to borrow that trick for some future online talks that I might be doing. So thank you. And thank you for the content too. That was very thought-provoking. So we have one great question in the chat, but I would like to perhaps start with a question that I have that came up as you were going through your talk. So we'll sort of work backwards. So if you mind going back to the statistical parity difference slide. I think the second one where you show, yes, this one. Okay, so to reiterate, let's see if I got this right. So we can calculate the statistical parity difference of our data. So let's say in this case, it's minus 0.1. But I'm wondering here, so this wouldn't necessarily always be 0 because in some cases there might be higher incidence of disease in, let's say, males over females. So then I'm wondering, would the ideal scenario here be to ensure that the data is representative of the overall population? Then we calculate our statistical parity difference. Keep that in mind. And then we calculate it on the model, and then we ensure that those two measures line up.
Yeah, so that's a really great question, and absolutely. So let's say that, for example, instead of detecting chronic kidney disease, which I am not a doctor, I watch Grey's Anatomy, but I do not know the actual rates of anything here. So when it comes to chronic kidney disease, you could assume, or maybe we believe, that it does occur approximately equally among men and women, and so we want to identify that or recognize that. And in that case, a statistical parity difference in our data of -0.1 might cause us to identify that bias exists in our data. Maybe we collected data incorrectly, or maybe the way that we collected data is contributing to biases. Then when we build a model based on that biased data, that model may exacerbate those inequities. However, that's not always going to be the case. For example, directly to your question, let's say that instead of looking at chronic kidney disease, we look at breast cancer instead, because my understanding, again, could be wrong, so please push back if I'm wrong. My understanding is that breast cancer is significantly more common in women than in men, or color blindness is significantly more common among men than it is for women. And so in that case, if you were to see a large disparity in that data, that statistical parity difference, that doesn't necessarily mean that something is wrong. Now, we'd probably want to compare that number to other medical research that has already been done to see, is our data skewed? So to take this a step further, if using the number on the slide here, we had a 10% difference between those two groups in detecting chronic kidney disease. Well, if research says that the difference is that women are 20% more likely to have chronic kidney disease, something is off here in our data in terms of us collecting it from the population. Did we define our population correctly? We would want to do a check there. However, if we were looking at breast cancer, where my understanding is things are very, very different, and that we might expect to see it significantly more from women than from men, having a statistical parity difference that is skewed one direction or the other doesn't necessarily mean that something's wrong. So if I was to say, and I feel like I'm now mixing a couple of different examples, which is not great, but I'll do my best to be clear here. Let's say that if I was doing research on breast cancer, let's say that it was 70% more likely among females. If I then looked at my statistical parity difference in my data, and that statistical parity difference in my data was positive 0.7, that would be okay because that matches that previous research that's been done. So that's not necessarily a bad thing, or it's not inherently a bad thing. However, this can be a helpful benchmark if we compare the statistical parity difference in our data. If we compare that to what we see in like prior research to understand, does our data reflect the ground truth or knowledge that we have? Also adding in the caveat that research that has previously been done isn't necessarily going to be unbiased either. But if I can try and distill all of this down into something that's a little bit more, a little bit clearer, I'm going to say here, the statistical parity difference in our data can be compared to our, this automatically jumps to an eraser if you press it the wrong way. So statistical parity difference of our data can be compared to our prior knowledge or maybe some research that has been done on a certain topic. If the statistical parity difference from our data does not align with our prior knowledge, that might suggest that our data is biased or skewed in some way, or I'll add in here, or say unrepresentative in some way. So that's a really good point to bring up, because you're right. Just because there's a difference there does not mean that that means that there shouldn't be a difference, because in some cases, especially when thinking about diseases, that's a fairly natural thing.
Amazing, thank you. It's extremely clear now. Really appreciate that detailed answer. And we
Sure.
have a follow-up question from an audience member asking, so how do we know if the statistical parity difference for a data set or a model is actually statistically significant? I would say, I think they mean statistically significant, or just, you can just think of even a loose term of significance if you'd like.
Sure. So if we look at this over here, I'm actually going to zoom in. So if we were to take that original example where we're talking about chronic kidney disease, and we want to look at the statistical parity difference in our data compared to that statistical parity difference in our model. In this case, the difference between -0.1 and -0.15 may or may not be meaningful or relevant or significant, either in a statistical sense. We might say that's not statistically significant, or we might say it is not clinically significant or clinically meaningful or clinically relevant. Maybe that difference is so small that it's not meaningful either in a statistical or in just like a real world sense. It's not all just about statistical significance. But there's not a good way to call that out and say, oh, this difference is or isn't at least clinically meaningful or clinically relevant. Again, as somebody who isn't a doctor, I can't weigh in and say, if that difference is at least 10% or at least 20% or at least 1%, that's clinically meaningful. When it comes to statistically meaningful, that is a good, or statistically significant rather, that's a good question. Again, I think a lot of it some of that may rely on judgment, but I think a lot of it is going to rely on, if you really care about the statistical significance of that, I would probably, to be frank, I have not done this, but I would probably appeal to some sort of bootstrapping procedure to try and estimate what are the statistical parity differences that we might see in our data, what are the statistical parity differences we might expect to see in our model, and then try and compare those by looking at some bootstrap intervals and see how much overlap there is between them. But that's firing from the hip in trying to answer that. And so I don't want to say like, this is the definitive way of going about that, but that's probably what I would at least first explore in trying to discover that.
Great, thank you. So we've chatted about statistical parity difference. I'd like to switch gears slightly and talk about prediction quality disparities. So we have a question from the audience, and you can go to the slide if you want. Great. So the question is, so what about cases where the prediction quality disparities of your model are not transparent because the relevant groups themselves are not encoded in your data? So for example, say you never collected race or skin tone data for your soap dispenser model. So how do we as data scientists ensure the fairness of our models when the data isn't necessarily always there?
Yeah, so that's a really good point. And so let's say that in this case, you don't have access to race or ethnicity or anything as a variable that would allow you to understand this. You would have to make the decision about whether or not to collect that data, recognizing that even collecting that data can in some cases cause harm. So you want to be very, very careful about what you collect and why. One of the things that I find helpful is when thinking about collecting data, what would happen if this data were to fall into the worst possible hands? I don't love to live there like mentally, but thinking about that is a helpful way for me to understand, do we need to gather this data? Is it important for us to gather this information? So but one of the best pieces of advice that I think I can give, even though it's not an easy fix, is to listen, is to understand what are your users saying? What are people who are affected by this model or this product saying? What are people who are, I think listening to the concerns of people is critically important. I also think that this is part of the reason that representation is really important when making decisions. For example, there are all sorts of examples that come out about how a company puts something out that is, and this isn't necessarily from a data science point of view, but companies may put something out there that is inadvertently racist or inadvertently sexist. For example, if we can tackle the idea of sexism for a moment, when Apple released their, I think it was their Apple credit card or something like that, there's a husband and a wife who, and I forget all of the exact details of the situation, but I think that the wife either had a higher credit score or a better paying job than the husband. And it was something along the lines of either they had the same income, but she had a higher credit score, or they had the same credit score, but she had a higher income. But when Apple released the card, the husband was given a credit limit that was like 10 times as high as the wife's. And so when it comes to the idea of representation, I have to ask the question. I was not in the room. I did not make the decisions, obviously, nor have I ever worked for Apple or anything like that. But the question that I ask is, how many women or non-binary folk were in the room when the model was being built, when the decision was made? Like, how did this not come up earlier? And so when we think about things like, having really any type of machine learning model, or when we're using data science, it is critically important for us to consider that there are a lot of different perspectives for how people are going to react to things, how people are going to be affected by things. So having a diverse set of people in the room, thinking about gender, thinking about sexual orientation, thinking about race and ethnicity, that is really important, because otherwise organizations may find themselves falling prey to something like this, even if they're collecting the data. Now, this gets back to the original question of what happens if you're not collecting that data. I think that the two answers that I can think of are going to be, make sure that you've got representation in the room, because the more representation, the better diversity and representation in the room, the likelier it is that someone at some point is going to raise their hand and say, I think that we need to be wary of this, or I think there might be an issue, and let's talk about why this is an issue. And the other thing is, consider gathering that data, but be very direct about or be very transparent with yourself about, do you need to gather that data and what are the trade-offs in doing so? So gather that data if you think it should, and representation are going to be my two largest takeaways here.
Awesome, thanks. There's a similar question that another audience member asked that sort of plays off of your explanation. So they're saying, rightfully so, that it is unlikely that any one person would come up with all of the potential concerns that exist about bias. So they're asking, who do you engage, or you or anyone in general, so who do you engage to help come up with potential concerns, and what's the process to help identify these issues, especially if this person we're talking about is not a data scientist themselves?
Yeah, so I don't have, I will share my experiences, but cannot, or in my thoughts, but I cannot be like the definitive guide on all of this. I really do think it comes down to listening to diverse experiences. It's and making sure that people of diverse lived experiences are in positions to make their voices heard. Because there is a trap that I think many organizations fall into, where they may hire a group or a number of individuals from a group trying to diversify the voices in the room, but can very quickly say, well, that person's just causing concern. That person is constantly bringing up these issues. And it kind of defeats the purpose is not the best way of phrasing that. It can be exceptionally challenging when organizations might, to use an example, let's say that an organization is going to bring on a Black person into the room. Let's say that historically there has not been a Black person in the room, and the organization says, we do want to make sure that there's one Black individual on our data science team. That person needs to be listened to. It is not enough. It does not stop with just hiring. It is important to listen and give everybody a platform, but make sure that everybody feels comfortable with voicing their opinions and voicing their thoughts and their ideas and their concerns when it comes to this, because no one person is going to be able to articulate everything. For example, I am a white cisgender man. I am also gay. I do not speak for all gay individuals. I do not speak for everybody who is a member of the LGBTQ community. I'm just one voice for that. But if there is something that I think can negatively impact that community, for example, if we're doing research, like let's say research that has to do with HIV, or research that has to do with any sort of sexual related stuff, I hope that I will be able to use my voice to say, I don't think we should collect this sort of data, because if that data were to get in the wrong hands, or even if we think we've de-anonymized the data, that could out people, that could put people at risk for physical harm or something like that. I feel like this is I'm long-winded here, but the goal, I think the way that I would sum it up is that representation is important, but it's not just about having people specifically in the room. It's about listening to everybody in the room. It's about giving everybody a platform and developing an environment in which people can flag these concerns, because it's unlikely that there's going to be one person who is always going to be able to keep their eye on this potential issue. And I don't know that it's responsible of us to say, well, there's one person in the room and you're responsible for detecting whether or not this is the case. Ideally, all of us as data scientists and people who are working with data, I know I'm making an assumption that all of us are data scientists, but all of us who are working with data, it's important for all of us to share this responsibility and share this burden, in my opinion. So those are sort of my thoughts as it relates to this.
Great, thank you. And I'm very curious to ask you some questions that I had shared with you before the session. There's
Sure.
two more questions now from the audience. Okay, one is directly related to your last answer, so I'll ask it here. So related to the last response, should there be universal standards on how to address biased data? Can't a gay person also discriminate against people like them, or lack a view of diversity?
Yeah, so absolutely. So the short answer to that is yes. Like I said, I am not the spokesperson for all gay people. I am not the, nor do I want to be, nor would I ever want to be in a data science room where, because I am a member of a minority group, that I would be expected to be the expert on all things related to that. And if something were to go awry, like if a model were to be found to discriminate against people of different sexual orientations, that was my responsibility, and that I would be on the chopping block, so to speak, job-wise, because I did not do my job. And I also don't think that's a fair burden to put on people, whether individuals are gay, or we're thinking about people of color, or women, or non-binary folk, or whatever. So that is, so absolutely. And I think it speaks to that's the broader, it gets to a broader diversity issue that we need to address. It is not enough to say, oh, we have one individual who's gay in the room, and we have one woman in the room, we have one non-binary person in the room, one Black person in the room. Okay, like we're now protected from all issues, because that's not it. And I think, again, it gets more toward it is all of our responsibilities to be aware of this, because we recognize that just like Serena cannot speak for all white individuals or all women, we need to recognize that it's more about broader diversity, and that can help to avoid these very real data science and statistical issues, as well as many, many other issues. But it has to go beyond just like, I don't want to be a checkbox, like, oh, the gay guy's in the room, so like we've addressed that, because that's short-sighted, and that's simply not going to be the solution to the problem.
Yeah, it definitely makes sense. Thank you. So I'm very curious to ask you a question about monetary motivations for creating fair machine learning applications. And this is something that I guess you could say I'm struggling with, because creating fair applications is definitely the right thing to do. But unfortunately, machine learning products, they're often driven by one thing, the desire to make money. And doing the right thing might not necessarily be on the top of everybody's minds. Of course, it's helpful if there is representation in the room. But I'm wondering if you could talk about some of the monetary benefits to creating fair applications.
Yeah, and I think that this is one of the big challenges with, one of the big challenges that everybody's going to face, because you're right, monetary incentives are so strong. And so it is, as much as I wish that weren't the case, when people say we want to maximize efficiency in the voting example I gave earlier, or in the business example where I'm like, well, all businesses and all organizations do this. It is, I believe, part of our responsibility. Ideally, we all collectively do this, regardless of whether or not we're data scientists. But I believe that it's part of all of our responsibility to be aware of this, and present or articulate that there are multiple, that there are many things that go beyond money that can be beneficial. However, you're right, Serena, in that being able to say, I mean, unfortunately, for better or for worse, this is, and I personally believe for worse, trying to root everything in money is the way that most people tend to understand it. So I think that describing things in terms of risk can be a powerful monetary incentive. For example, if I go back 2 slides where we look at this prediction quality disparity, we might say that, yes, we have 99% sensitivity, our model's performing well, everybody is happy with it. But if we deploy this model and it does not work, or it disproportionately works, I mean, just the examples that I was talking about earlier, the racist soap dispenser, that is something that for that company, that certainly did no favors for that company's bottom line, for that company's public relations, for that company's ability to retain talent, for people choosing to continue buying from that company, or people opting out of buying for that company. Thinking about Apple and Apple's credit card, where we see an enormous disparity in the credit limits that are given to men and that are given to women. That's something where I hope that it'd be also fairly easy to show as strong incentive monetarily, in addition to everything else, because would people be less likely to use the Apple credit card, knowing that this is, and I forget which organization bankrolled that or whatever, but is that something that, like, would that affect the number of people who use the product, knowing that that sort of disparity exists? And I believe the answer is yes. We see that there is a bit of culture. I'm not going to call it cancel culture, but there's a bit of culture around people being more judicious with how and where they choose to spend their money based on organizations and the stances they take or the mistakes that they make. And I think that that can be a powerful monetary motivator for a lot of companies to say, look, we might think that this isn't a risk, or we might deem this to be an acceptable risk because the probability of this causing an issue is so low. But if there were to be, quote, an issue cause, or if there were a PR firestorm about that, it's almost impossible to understand what are the effects of that. And for a lot of organizations, that would dramatically influence their bottom line. So I think that there's a lot of ways to tackle that. Again, ideally, we'd be able to appeal to something that's a little bit more about, or it doesn't have to be about money, but yeah, money is a powerful motivator. The last thing that I'll mention here is there was a conference in Boston a couple of years ago, the Data for Black Lives conference. And I remember reading a tweet about that technology is cumulative. And if we think about, for example, the soap dispensers that may have a strong prediction quality disparity, that those soap dispensers, the same technology that's used in that, the same sort of models, organizations may want to co-opt those models or repurpose those for other things, other reasons. Well, what happens if the models that are in the sensors detecting hands, or what happens if any of the mechanics of that soap dispenser then get transferred into a self-driving vehicle, I think is the example that Data for Black Lives used. And all of a sudden, because technology is cumulative and we're building on imperfect technology over and over and over again, that technology that initially was just, it doesn't detect a hand, now may have really, really bad results when it comes to the ability to detect maybe a human who's walking across a road or something like that. I thought that was a really powerful example and helped to shape some of my thinking around, well, does it really matter if the prediction quality disparity is only 5% and only in this one application? It can often go beyond that. And so understanding when code is open sourced, when organizations repurpose code from one thing to another, when people develop technology in this cumulative fashion, it does have longer lasting effects than what we might be able to see in the box of our one example that we have right here.
Yeah, that is very convincing, the example you laid out there. So thank you very much. I read an article on Google's marketing site, and again, not sure how I do feel about Google, but they were explaining the importance of fair machine learning applications, and of course from a marketing lens, so valuing loyalty. And in this article, they interviewed consumers who had encountered unfairness in products, so in the form of feeling like they were targeted for their intersectionalities. For example, let's say being targeted by some racist soap dispenser. And the article went on to argue that if a brand makes consumers feel unfair, they're going to be less likely to be loyal to them. And I thought that was quite convincing. And it just makes me think, I'm not sure if you've come across any of these, but are there any repositories of examples of unfair machine learning applications and how they've hurt the company or a company monetarily? Because if not, I would love to explore building that.
Yeah, I don't know off the top of my head, but I think that is I think that can be a really powerful thing to share with individuals. So if that's not something that already exists, I would encourage somebody to, whether that's you, Serena, somebody else on the call, to build that. I would be surprised if there isn't something out there, but that might be more of like I guess I don't know the state of what that would look like, but I think that can be really powerful because just like you said, Serena, if I go back here, when, it can be challenging to tell an organization, client, manager, whomever, that your team should go with a model that performs worse globally. But there are a lot of examples and rationales why I think that can be advantageous monetarily and for other reasons. Again, I want to put the focus on the other reasons, but I think that it can be helpful to provide people with the tools and the strategies for how to negotiate those conversations, because that's a tough thing to do. And And I think that, yeah, that would be really valuable for, I think that's valuable for myself personally. And I know that a lot of other people would get value out of that as well.
Well, if anybody on the call is interested in building some sort of repository like that, let me know, because I would be really happy to collaborate with you on that.
Yeah, it looks like Willie Costello has shared the Algorithmic Justice League is building something like this. And then it looks like Aaron shared with the panelists. I've just shared it with the attendees. So somebody named Aaron, thank you, Aaron, shared this awful AI repo on GitHub. So yeah, not surprised that that people are people are already building something like this. I also want to take one quick moment to share. I saw that there was a mention in one of the Q&As, and I think somebody clicked one of the buttons for it, but somebody mentioned that when I say women and non-binary individuals or non-binary folks, that it may not properly, and I only saw a glimpse of it before it went away, so I apologize, but basically there are probably more inclusive ways to frame that. So I appreciate you bringing that up, and that's something that I definitely want to look into. So thank you for mentioning that, and I will look back at this when things are done and be better moving forward. So thank you.
Yeah, and it shows that for those of us who are up here presenting about AI ethics, we're not necessarily the most educated ourselves, and we're trying to figure it out as well. So I think it's great that we have this ability to sort of call each other out in a sense and help educate each other, and we can become better together. Yeah. So I think that's great. And as another note, so when you go to the chat, if you can see in the box where you can type, there's 3 dots. So if you click on the 3 dots, you can save the chat, and then it'll pop up in some folder on your desktop. So I encourage everybody to do that, because there's been a lot of really great resources being shared, and I don't want to lose any of them. So another question, so going back to talking about mitigating bias when we have various subgroups. So the question is, so if harm is unequal on different subgroups, so your model might hurt one group over another, would it then be better to have a different model for every subgroup?
Yeah, so that's a good question. And I think that this assumes a couple of things. I mean, yes, it would be great to be able to do that. One of the challenges is if you have lower sample size in subgroups. So let's say that, let's say that you were looking at an example of looking at where people live, and you decided that zip code, for example, we recognize that zip code is very strongly correlated with, there's a very good predictor of things like race, income, socioeconomic status. And so what you may want to do is let's follow that approach. Let's build a separate model for each individual zip code that exists. Well, that may not be feasible. Just because of depending on how much data you gather, maybe you gather too little data from certain zip codes. So in this case, where we look at this model or this hypothetical made up example on here, where we're looking at the sensitivity among groups, your model may end up performing better if you build a separate model just among what I've labeled here as group 2, or the people of color here. That's not necessarily the best, or that's maybe your model will perform if you build a model just on that subgroup or that group of individuals. But it won't necessarily be the case. I mean, for many data science applications, 50 or a sample size of 50 is quite low. So there are going to be limitations to that. Also, if you're working with things that tend to be more continuous in nature, thinking like age, you could bucket age into different groups, but also how you choose to bucket age into different groups can be challenging. When you think about race and ethnicity, where people don't necessarily just fall into one group or one category here, if there are people who fall into multiple buckets or multiple categories, that can also be challenging. That doesn't mean it's not impossible, but there may be, it may just not be an easy thing to do. One recommendation that I would have, and I tend to be, I really want to get more into Bayesian inference. I think of myself like, I feel like Bayesian inference and Bayesian model building might be the answer to everything, but I'm just enough of a dilettante to not actually know or understand if that is true. But I think that Bayesian, like multi-level or hierarchical modeling, may be a way to approach that problem, where you can work with random effects in your model, or the equivalent of random effects in your model, or where you can look at models that are able to respect those differences between some of those different subgroups that you may identify in your data, while also pooling information together for larger things that are observed across all of your values. Not 100% on that. I would definitely do a lot of research before sharing that. But that's probably going to be the first thing that I'm going to look at. The second thing is I would just, again, it's about listening to people. I would ask, I would look at resources where people are talking about this, because I imagine this is probably not, you're not the only person who has been asking these questions. And so if there are resources like, specifically thinking about organizations like Data for Black Lives, or other organizations that focus on how data is used in ways that may disproportionately, in many cases, does disproportionately harm certain groups of individuals. How can you listen to them? Because in a lot of cases, they have sets of resources or have done a lot of the work in saying this is a better way of going about tackling these types of issues. So all of that is to say, you could do a different statistical or machine learning model for each subgroup. Obviously, that assumes that there are subgroups. So there can be challenges with that if you're working with continuous or many groups with small sample sizes. I would also consider looking at a Bayesian approach, like hierarchical modeling. And I would also look at resources that exist online from organizations that have probably already had discussions about this, and listen to what they have to say. And it looks like Serena has shared a marketer's guide to machine learning fairness as well. So thank you, Serena, for putting that in the channel.
You're welcome. And yeah, thanks again for that great answer. So I am curious. So I've found in my, I guess, fairly small sample size in the grand scheme of things, I've found that people who care about fairness in machine learning, they're also the types of people who generally care about fairness and equity in all parts of life. And I'm wondering how you would suggest that we can motivate people about the importance of fairness, let's say in machine learning, specifically for people for whom this might not be top of mind. And immediate thought I have is these like awful AI repository like that, sharing that and sort of incorporating that into some sort of education curriculum. I think that could be very beneficial. But I'm wondering if you have any other ideas or what has worked for you.
Yeah, I think one of the most powerful ways that, and this is something that I mean, a lot of specifically people who do research in American politics talk about, the best way to change people's mind is to talk to people who you know and convince them. That doesn't work as well on a broader scale, but having conversations and knowing examples and things that you can bring up to share and to articulate with people. Because I know that's a challenge that I have. When I talk, my dad frequently jokes that he does not know what I do as a data scientist. It doesn't help that my job has changed like 3 or 4 times in the last 4 months, but that he doesn't know about what that is. He's not unintelligent, but he just doesn't have like a technical background. And so trying to find examples that are relatable to him and to meet him where he is something that can often have positive effects. So being aware of examples that might be more relevant to them, or having conversations with family members, with close friends, even who aren't technical, but be able to describe or articulate how these things do affect them. There's often a belief by many people that that data science is unbiased. I mean, it's just data. It's just in a computer. A computer is just like, you just press a button. That's not biased. But talking about how, for example, crime data isn't really crime data. It's more about policing data and biases for what people were pulled over, what people were stopped, what people were actually arrested, and how that has disproportionate effects. Thinking about ways when people say, oh, my credit card got flagged for fraudulent transactions, or my credit limit was set. Those are things that many people that if people have credit cards, they have a credit limit. If people have different credit limits, that would be an example of precisely that. And so just trying to find common examples that are relatable to people outside the realm of data science, I think can be really impactful. And then being able to explain how data science plays into that. One of the things that I've also found really challenging, and I welcome anybody who has answers here, is what do you do when people say, well, there are so many problems, we can't fix it. There are so many sources of bias, or, well, you're never going to be able to correct everything. And that can, I think, in many instill a sense of hopelessness, or the fact that it's not going to be addressed. And so it would take so much mental energy to focus on that it's not worth my time to do so. I don't know the best way to get around that. So again, if people have recommendations on how to tackle those conversations, whether with family or with other individuals, I certainly welcome that. But I think that and this might be more about my education background, but just trying to find something that resonates. What's that when it comes to explaining any sort of topic, whether it's bias and ethics and fairness in machine learning, whether it's just explaining what an interaction term is, or what a linear regression model is, or how to explain what a model is, how can you phrase that in a way that everybody understands, so that more people understand, and trying to meet them where they are and sort of build up from that. I feel like that was long-winded, and I don't know if that provided a ton of tangible tips for people, but that would be my recommendation. Have conversations with people around you, try and come up with tangible examples that do affect them or have already affected them. And also, I mean, like Netflix recommendations may be another good example. Oh, you identified that you are a woman, and so how do your Netflix recommendations differ? I do not know if Netflix does, based on any information you put in or what information there, or if it's almost exclusively driven by the things you've watched in the past. But just things that hit close to home are going to be my recommendation for everyone.
Yeah, for Netflix, I'm not sure if they use demographic information sort of granular to the level of gender, let's say. I know YouTube definitely does. So even if you aren't logged in, they will use your location, for example, and they'll use any other history you might have to guess your age, guess your demographic overall. Yeah, which I don't necessarily say I would agree with. But anyways, so I'm also wondering, are there any machine learning papers that you would suggest to our community, since many of them are very technical minded, that we could perhaps read or start going through if we're interested in learning more about fair ML? So I'm wondering, are there any foundational papers we should be aware of?
Yes. So I wonder if this will still pull it up. Okay, this will. So this is the iPad that I used for a lot of my work, and I do think that there are a lot of papers that I think are good. I will show a few that I downloaded that I think were okay. So there's one called A Survey on Bias and Fairness in Machine Learning. And this did a really good job of, I think it was just, if I scroll down or swipe quickly, I feel like there were a lot of, so types of bias. And I think that somebody had asked earlier about the different biases that exist, or what are some of the biases that exist. This is a good way of saying, okay, what are different types of biases that exist in the real world, and how can we be aware of them? Because it's not like the question in most cases, or I feel pretty confident saying the bias, or the question is not, does bias exist? It's how many different sources of bias exist and where are they all coming in? This is, again, a survey on bias and fairness in machine learning. That is something where, and I can also, Serena, I can work with you to make sure that we get this list out to people afterward.
That would be amazing, yes.
So there's that. There was also, is it this? No. There were a couple of different things. I did like an intersectional definition of fairness. I think that is interesting because it's there's And I think this connects to a question that was asked earlier, and I don't know if I directly answered the question, but it's like, it was about, a gay person can discriminate against another gay person, a woman could discriminate against another woman. So aren't there standards toward which we can all, strive? Or aren't there certain ways where we can just say like, okay, like you check off the boxes of fairness and bias or unbiased? And the short answer is no, because unfortunately, just like with metrics where you think about if you want to optimize for sensitivity or for specificity, you're optimizing for your false positives or your false negatives. And when you optimize for one, you're almost always going to be in a negative space with the other, or you're going to have a negative, when you focus on one, the other might deteriorate a little bit. There's so many different ways to quantify bias and fairness that if you focus on some of them, other ones are not going to perform as well. Unfortunately, unless you build a model that works 100% of the time for every single group of individual, I do not believe that it is possible to build a model that would satisfy every single definition of fair or every single definition of being unbiased. Now, that is challenging because it's like, well, wait, like I wish that existed. It would be great if there were like 4 or 5 check boxes and we can say, yep, this is good, and we're done. But unfortunately, it has to be a lot more circumspect about it's not like there's just the 2 ways to quantify bias and say, okay, we've satisfied them. So we have to be a lot more aware of what are the different ways that we can talk about bias, what are the different ways that we can quantify bias or quantify fairness, and which ones are most important to us in the different situations we're talking about. Something even, thank you for Willie for grabbing the papers. I really appreciate that. That is super helpful and allows me to pull up. There was another paper that I thought was really helpful, but I'll look to see maybe it's in another folder or something like that. So if I go back to, this? Okay, so I'll pull this up again. Thank you for your patience with my scrolling and all of that. The other thing that I wanted to mention is that we need to be aware of the different types of bias and the types of fairness that are most relevant to us. And we need to recognize that we're not going to be able to satisfy every single global measurement of bias or of fairness. So we really do need to be able to prioritize and think critically about what are the ones that are most relevant to us. I mean, even here in this example, when we think about prediction quality disparity among, in this case, group 1 and group 2, well, there are probably a lot of different features that we care about. We might want to, and I would recommend doing so, breaking group 2 out into not just people of color, but because that's lumping a lot of different individuals with a lot of different experiences in, we want to break that out into different groups as well. Well, depending on how you choose to aggregate, aggregation bias is its own form of bias. As we choose to aggregate different groups of individuals, how does that change the picture that we're looking at? If we're looking at things like age, do we treat age as a continuous or approximately continuous variable where we look at prediction quality disparity for every single different value of age? Or do we bucket age in terms of 0 to 10, 11 to 20, 21 to 30, and so on? There are all sorts of decisions and challenges that even if we were to just look at prediction quality disparity, there's, depending on how many features we have, what are the things we care about, there's probably no way for us to even satisfy prediction quality disparity for every different group of individual based on all the different groups that we would be interested in exploring. So I think that going back to those papers, looking at how to define bias and how we can talk about bias and rather define fairness, talking about bias, talking about fairness, and understanding what's most important to us is an important first step. And I think related to a question that Serena asked earlier about monetizing and all of that, how do we, I mean, it's on us to be able to tell that story too and get a manager or a client or somebody to care. So how do you do that? You know, how do you get a client or a manager to care about those things? And how can you make the argument that this method of fairness is so critically important to satisfy that you may need to continue production on your model for another week or 2 weeks in order to continue in order to satisfy that definition of fairness? How can you get more time, or how can you validate, how can you get a lower performing model, and how can you justify doing that? And a lot of that's going to fall to us as the data scientists to articulate that to the decision makers. If we ourselves are not the decision makers, it falls to us, if we are the decision makers, to be able to make that choice that might mean some short-term financial harm or short-term time-based harm in terms of saying, well, let's continue developing this model over time. Than that easier thing of, okay, we can turn this around for the client by a certain date.
Great, thanks, Matt. So to the audience, I will be asking, and also to Matt as well, I'll be asking, let's say, 2 more questions. I'm curious to talk about code and also existing resources out there. Yeah. So get your questions in, everybody, if you have more, because we will be wrapping up quite shortly, I would say. So Matt, I've read about a few different fairness tools, but haven't had a chance to play around with them yet, although I hope within the next week I will be able to. But I've come across TensorFlow's fairness indicators and also Google's ML Fairness Gym. So I'm curious, have you happened to use either of these two? And if not, or also if so, do you have any tools that you would recommend for someone who's interested in seeing how to detect and correct fairness in some machine learning application?
Yeah, as part of some work I've done in the past, I've briefly looked at the 2 of those. The other thing that I have looked at is IBM's AIF 360. I think that stands for like Artificial Intelligence Fairness 360, but
yes, I think that's a very popular one too as well. Thanks for reminding me of that.
Yeah, it's a good dashboard for being able to visualize when you're working with data, like what do things look like based on the data that you have when you build a model, checking different measurements or methods of fairness. Again, it's not an exhaustive list. There are many, 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 many different ways of measuring fairness that exist. And so I think that it's a good, first step at looking at that, but I would be cautious against treating that or Google or TensorFlow's thing as like the end all be all. Like, oh, if I were to apply this to my approach and things check off here, things look good here, that we're good to go and it's not a problem. So yeah.
My follow-up question then would be, so what do you think is missing from those packages? That what would we need to add to make it the end all be all?
That's a good question. And again, it gets to the idea of like the no free lunch theorem, that idea that if you took every possible data set that could exist under the sun and every possible machine learning model and apply them to all of these different theoretical data sets, that on average their prediction error is going to be the same. That is, there's no one machine learning model that would be best across everything. So, because I mean, if the random forest was just always better than every other model, doesn't makes a little sense to learn the other models, but like not a ton. If random forests are always going to be better, okay, let's go with that. Same sort of thing. If there was one thing in fairness where it's like, this is the thing to know that would end up being the end all be all, I would not have spent my time talking about accuracy tells a part of the story. One number tells part of the story. Like I wouldn't have spent any time on that, and I'd be like, all right, here are the 3 things that you need to know to become a fair data scientist. Unfortunately, it's just not as simple as we would like it to be. I think that the ability to look at and think about the different types of harms that could be done by your model, or the prediction quality disparities that could arise from your model, being able to look at those and being able to look at those across different metrics. I mean, if we go back here, there were so many different metrics that exist. I think it would be really great to be able to have something built where you can evaluate, the area under the ROC curve by subgroup, precision, specificity, sensitivity, accuracy by subgroup. Being able to look at all of those, I think, would be a good, helpful next step. But I certainly don't think that would be the end all be all, because we don't always have access to all of the features that we would want to test. even if we did have access to all of the features that we wanted to test, that may not work well for a number of different reasons. And we're also sort of not talking about the issue of intersectionality here. So thinking about the impact of race and gender together on I mean, honestly, really anything, whether it's medical diagnostics, whether it's economic related stuff, pick your poison. That intersectionality, I think, is important. So already there, I mean, if somebody wants to build that where you can define different subgroups, you can look at cross sections of X variables or variables that are important and relevant, and look at it for all of these and other metrics, that may be a good next step. But even that would, in my opinion, not be the end all be all. And with and Serena for sharing, thank you for sharing that. The AIF 360, yeah, it's I think artificial intelligence fairness 360. That is, they've got a Python package that can be used, so you can apply many of their techniques directly to your models or to your data just by importing those packages.
And so with this package in particular, does it work with sort of any machine learning model, or would it not work so well with these more cutting edge, let's say, models? Are there restrictions there?
Yeah, so I believe with the AIF 360 package that's put out by IBM, I believe that it will work for any supervised machine learning model. So I do not know that it will work, because I think, I could be wrong, but I believe that all of the metrics, at least the ones that I was looking at in the AIF 360 package, did require a Y variable. Some of them required access to the ground truth and the predicted label. I believe even some of them wanted access to the predicted probability. So it depends on the model that you're working with and what it generates to you. If it comes up in a classification setting with the predicted probability and the predicted label, you could obviously get the label from the probability, but that would be sufficient. You've got access to the underlying data, the true values of the Y variable. That's very helpful as well. And then if you've got access to the X variable, that unlocks more of the metrics that can be used. And it's similar, I believe, in a regression setting, but some of the metrics will only work for classification models. And I believe that's where most of the work has been done. It's not all been done there, but if I go to, for example, statistical parity difference and the definition of statistical parity difference, this can be used for any discrete or continuous X variable. You can derive it for continuous X, but the Y's there, we're looking at a certain value of Y, and this, I believe, Y needs to be binary. So some things will not work for regression models, though, of course, you could turn any regression problem into a classification problem if you wanted. But there's going to be some limitations there with that.
Yeah, it makes me think. So I work a lot with sequential models. So let's say NLP, for example, even recommender systems, because you can express a click sequence as clicks as a sequence. And I'm wondering if these fairness applications, if they can be applied equally to sequential prediction problems where you might not actually have information like demographic information, but you could encode information in the items that the people are clicking in the form of embeddings or something like that. Have you heard of anything that touches on fairness with sequential models?
Not for all sequential models. I had a really hard time looking up or doing research on fairness in time series models. So whenever you're working with a Y variable that's got that time series component to it, that was challenging because, of course, there's all sorts of assumptions there. There's a decent amount of stuff when it comes to NLP that you can explore. So, as an example, if I look at the papers that I had here again, there's a thing. So, like this paper, the woman worked as a babysitter on biases in language generation. Oh, it looks like my internet connection is stable, so hopefully folks are
That's
still.
okay. I think we've still got you. At least I still hear you.
So looking, there's a lot of work and research in that. The thing that I think was most interesting was looking at. Sorry, you're seeing all my sort of notes in this, but there was. So if you wanted to look at gender neutral word embeddings, there are a number of techniques that can be used to try and understand that, or to focus on that. The technique was called GN glove that I did some research in. Stood for gender neutral glove, where glove is a natural language processing technique, specifically a word embedding technique. To provide to step back for a moment and to provide like a little bit of context, just for people who have never heard of glove or anything like that. So a word embedding is a way for us to take words and put them into a mathematical space. So rather than thinking about words just as words, the way that you and I use words, in order for computers to understand them, a word embedding is where we take words and we just like smash them into a mathematical space. So you might think along like X and Y axes, for example. Well, what we need to do is when we do word embeddings, there's a lot of work that, or there are a lot of things that can be done in terms of how those words are embedded. Many of the most popular techniques, thinking about things like word to vec or glove, these two different techniques will take words, look at the words that are surrounding the words that exist, and use that to learn relationships among words so that you can learn, the word pen and pencil. These are two separate words, but they're really, really highly correlated with one another. Well, the problem is that when you're using language, language is rife with all sorts of biases. One of the most common biases is when we think about gender biases. So there's a paper that's titled something to the effect of man is to doctor as woman is to nurse. And that's because of biases in how we as humans use language. So again, glove is a technique, GLOVE, like I put it on my hand. That is one technique for word embeddings. However, it does not protect against biases. So there is something called GN glove, which is a gender neutral word embedding technique. For those of you who are familiar with regularization, what it does is it effectively allows you to identify certain words that have to do with gender. Or if I remember correctly, it's been probably 5 months since I read this paper. But it's you identify certain words that have to do with gender, and it regularizes when you fit your model or fit your word embeddings, it regularizes to try and constrain your like gender related words to a certain dimension so that gender is reduced to one dimension, and then it just drops that dimension so that you can look at things in terms of all of the words and how they're embedded just without the dimension of gender. There are a lot of limitations to that, and there are more recent things that have been developed. But I think all of this is to say is that there's a lot of work actively being done in the area of natural language processing when it comes to debiasing word embeddings. This uses gender neutral as an example, but it's not just gender neutral related. It is you could, I believe, apply this technique to, there might be a specific corpus or set of words that have been defined to be related to gender, or looking at examples from I think waiter to waitress or actor to actress, and using that to learn what the gender dimension or the gender axis is. I believe that if you were able to define your own words, you could generalize this to, if you want to debias word embeddings in another way based on ageism or racism or homophobia or something like that. So again, lots of stuff that we could talk about, but there is a lot of active research. I believe this paper is in, I see. Okay, yeah. This paper was published in August of 2018, so still a very, very active field of research.
Definitely. Thanks for sharing those resources. And I also added a link in the chat. So in June, for the first AI ethics event, I hosted a researcher from Google who talked about his work that he came up with it and he led it. So that's a really good example of a data scientist saying, hey, I think this is important. He had found, and I think many people had noticed, that with Google Translate, when you translate from a gendered language to a gender neutral language, oftentimes you would end up with sentences that say, or yeah, anyways, I can't remember if it was gender neutral to gendered, anyways, but you would end up with sentences that are, he is a doctor rather than she is a doctor. And he worked on the process to output both he is a doctor and she is a doctor. So it was really interesting. So if anybody's curious, I recommend you take a look at the video that I added in the chat here. And again, as a reminder, since a lot of really great resources have been shared, please remember to click save and just make sure you don't lose out on any of this great stuff that people have been sharing. And with that, I would like to wrap up the session and say thank you so much, Matt, for being here. So do you have any last words you would like to add before I do the closing remarks on behalf of ACE?
No, thank you all so much for sticking around. I see we've still got 23 people, and I think we're a few minutes over. So I appreciate people just sticking around for this discussion. It's so important for us to talk to and just be candid about this. I think that it has felt at times uncomfortable to discuss things like gender and race, where I am a white cis man and feel like I don't have a platform for that. Learning more about how the work that I do as a data scientist absolutely does have an impact there. It is incumbent upon us, those of us who are more privileged, it is incumbent upon us to be able to be better about just be better, be more proactive about bringing these conversations up about listening. And that's something that I have found to be it's been challenging, but it's been good to be able to do that. So I know that, it has a lot of really positive impacts. And so I would just encourage everybody to be more aware of that. And feel free to, if you think that it would be helpful, feel free to reach out, feel free to connect with me. Like there was the individual earlier who said there's a more inclusive way to talk about when I would say women and transgender folk. If there's anything that you want to say, hey, thought your talk was great, or I thought your talk was bad or okay or whatever, but wish you would do this differently. That would also be helpful. So I appreciate that. But thank you, Serena, and thank you, Joshua, for putting this together. I really appreciate it. And I'll toss it back to Serena to close us out.
Sounds good. And Matt, please stay on the call. Don't sign off too quickly so we can chat once this is over. So I will do the closing remarks on behalf of ACE, and then I'll let Josh close it out on behalf of GA. So again, just wanted to say thank you so much, Matt, for that talk. It was very thought-provoking and answered a lot of questions that I had. And thank you, Josh, for organizing and for introducing us over at ACE to Matt. And for those of you who would like to see more free content like this, please visit our website at ai.science, and you can log in or register to access slides from this session. So I will be uploading them, and you'll be able to view sessions and slides from many other researchers and many other authors. And please make sure also to subscribe to our YouTube channel, which is called ML Papers Explained, and then you'll get notified about all the other live sessions and exciting free content that we publish. Now over to you, Josh.
Yeah, just want to, I will send all the stuff over. Matt, thanks as always. I love the way you teach. It's so awesome, and just blessed to have a space where we can, talk about these things and collaborate.